You have.
So thank you for joining the webinar.
Okay. Okay. Thank you.
Sir, we will start in a short while. Please move
No
to.
issue.
Good morning,
Very good morning.
ma'am. Welcome to this webinar. We are glad.
Glad.
Yes, ma'am. We are glad you joined. Thanks for joining.
A very good morning to all the respected dignitaries and guests. I, Afaq Wajid, on behalf of the Department of Electrical Engineering BBIT, welcome all of you to this webinar on recent advancements in the field of electric vehicle and power grid. Now, the main objective of the webinar is that our society, it needs energy for sustenance and progress. And harnessing energy for benefit, comfort, and progress of mankind is very much essential. Electric vehicle technology and smart grid are emerging areas in the field of electrical engineering, which are catering the ever increasing demand for electrical energy. So, the purpose of this webinar is to throw some light on some of the emerging technologies pertaining to vehicular technology and smartening the power grid. We have with us renowned professors from University of Repute who will grace the occasion and share their knowledge and expertise with the participants of this webinar. So with this, I would like to begin the session with first of all giving a vote of thanks and introducing the chief patron, our chairman, Mr. Jagannath Gupta. He is a renowned industrialist. His industrial endeavors has transformed Bajbaj into an emerging industrial hub. And we, all of us at BBIT, are working forward for the attainment of his mission and vision towards this institute. Sir is not here with us, but his best wishes and regards are always with us. He is always in our prayers, and we are always in his prayers. Next, I'd like to introduce our patron, our Vice Chairman, Mr. K.K. Gupta, and our Executive Director, Dr. Shubhangi Gupta. VC sir, he is always encouraging and supporting us in all possible ways so as to achieve the mission and vision of the college. That is to make this institute, to bring this institute to such a level that it becomes, that it is of, like it attains national importance. It becomes an institute of national repute. Our executive director, Dr. Shubhangi Gupta, she provides us the much needed guidance, enabling us to work in an efficient way. Due to some work-related issues, they are not able to join us over here, but still they have extended their warm greetings for us to continue with the session. Next, Mr. Tapas Sarpati, the Group Director of VBIT. Sir always inspires us to work towards achieving the goals, even in the most difficult situations. Sir is present with us over here, and I would request Sir to say a few words.
Very good morning and happy new year, one and all presents here. On behalf of our chairman, sir, Sri Jagannath Gupta, our vice chairman, sir, Mr. K.K. Gupta, our executive director, Dr. Shubhangi Gupta, and our CEO, Dr. Balaram Gupta, I extend my heartfelt thanks to the Department of Electrical Engineering for organizing the first ever webinar in 2021 from BBIT. So I would like to congratulate electrical department to start with the spirit. Yes, we all know everything we are doing is virtually, but I believe this virtuality is became the reality at this moment. So with this mindset, academics cannot be stuck up under any circumstances. I agree that the compassion of knowledge, sharing of knowledge to the society and continual growth academically is a very much necessity at the moment. I would thanks to choose the topic, the advancement of automotive system. There are many advancements going on around the globe, and this particular topic has got huge implications and significance in the current days. I think in today's webinar, we will definitely enlighten on MEVs, HEVs, EVs, and FCVs, etc. These all are nothing. These are the controlling systems what the drives are utilizing in modern days. Moreover, in advanced stage, it is IoT and machine learning is also getting incorporated in this way. So there is ample of scope for us to see the future days in better way. I would convey my special thanks to Professor Debashis Chatterjee. Sir has a huge experience and huge research work on this particular field we know. Sir, welcome you, and I feel that your presence will definitely enlighten today's topic. Converter control techniques for vehicular drives is a topic, but I feel that along with this, there are so many things are related with to deliver the scope. I will be happy if the organizer could make it possible to serve this webinar even to the students of our current students and to the other students also, if possible to put it in YouTube so that other people also can see it. Thank you one and all for organizing such a beautiful webinar. I wish every success of this webinar for the day. And there are many sessions. First session of today, there are two sessions, first session, second session, And tomorrow there will be 2 more sessions. I'll try to be observe at least, if possible, to be present in all the sessions, though I have got some other important work, but still your importance is my importance. So thank you, Electrical Department, for organizing and thinking to organize this type of webinar. Thank you one and all, once again.
Thank you, sir, for the appreciation and recognition, sir. Now, I would request the deans of BBIT, first of all, Dean Academics, who is also the HOD of the Department of Electrical Engineering, BBIT, Professor Dr. Narendranath Jana, to address us. Please, sir.
Good morning. Good morning, sir. Am I audible?
Yes, sir. Good morning. You are audible, sir. Good
Yes, sir.
morning.
Good morning. So, with due respect to our chairman as well as vice chairman and our executive director, on behalf of Electrical Engineering Department of BBIT, I do welcome all the dignitaries who are present over here, as well as the students who are joining through the YouTube streaming, as well as our MTech students also have been asked to join. So it is a wider network through which this particular webinar is being conducted. However, as far as we know, I would like to say something here, because yes, in this pandemic area, my time, what we have had our journey for this particular semester that was started from 10th of August, and almost we are on the verge of the completion of the semester. Now, since it is the long semester, we do not know really when this particular semester will get completed. However, there should be a break sort of thing from the student side. So we have really got this particular 2 days seminar where students will be attending, which will be other than the regular curriculum which are being conducted online. Now, as far as coming back to the topics, as you know, Shakpati sir has already told, yes, these are the topics which are definitely the need of the hour. And as an electrical engineering or rather circuit branch of electrical or EC or instrumentation, this particular two field definitely is having much relevance with respect to our day-to-day applications are concerned. Now, as you know, uh, most of the, let us say, embedded technology, which is analog circuit based as well as digital technology based, definitely there is a push to have the local manufacturing base because of this pandemic situation. Now, as you know, for any product, whether it is an electrical vehicle or any product, you need smart sensor, you need smart signal conditioning circuit, you need smart controller, you need smart actuator. Any device which you really imagine, all these four subsystems always will be there. Now, this particular seminar definitely will induce to our faculty members as well as some senior faculty who have joined from outside of Bengal. So definitely they will be getting some insights to really go for some kind of research work to take up. And as far as students are concerned, definitely right now they can think of other subjects taking up along with the whatever is being taught as a part of the course curriculum. So this particular 2 day seminar will definitely have some kind of insight which will induce to take up some different subject in their future life. So I congratulate definitely the convener of this particular webinar, Professor Sudip Kumar Ghodoi and Afaq Wajid, and joint convener was Deepak Kumar Shaw. So congratulate them to really arrange this kind of seminar, and definitely it is a matter of pride. So with this, I hope this particular 2 day seminar will have a grand success. Thank you, sir.
Thank you, sir. Now I would request our Dean Polytechnic, Shiladitya sir, to please say a few words.
Thank you very much, Afaq. Good morning and happy new year to all of you present here in this webinar. It gives me a great pleasure to be able to be present here in this 2 days webinar program, recent advancement in the field of electrical vehicle and power grid. I must not take too much of time, but only 3 parts are there. First of all, I would like to congratulate my colleagues of Electrical Engineering Department for arranging this kind of webinar program because this kind of program undoubtedly helps in inculcating kind of academic culture in our students as well as our faculties. Thank you very much, my dear colleagues of the Department of Electrical Engineering here in BBIT. Secondly, the students who have joined, for them, it's a great opportunity. It's the kind of opportunity where they will be able to hear and interact with great thinkers of their stream, the stalwarts of their stream. So it should be a great time for them. And last but not the least, the most important perhaps, on behalf of IIT, I would like to extend my heartfelt thanks to our esteemed delegates, the distinguished speakers who have joined here and who are to deliver their lectures here in this webinar to enrich us, to enlighten us in the field of electrical vehicle and power grid. Thank you very much for inviting me, and I wish all the success for you. Thank you very much.
Thank you, sir, for your warm words and appreciation. Now I request the Dean MBA, Professor Dr. Momita Poddar, to say a few words.
Very good morning to all of you. It's a great pleasure for me to be present amidst such wonderful stalwarts of technical education. It's really an honor to be a part in this webinar. I would like to congratulate the department and institution as a whole, the engineering department as a whole, to welcome the new year with such a wonderful webinar, arranging such a wonderful webinar for these faculties and the students. It will be a great learning opportunity for sure. We have wonderful stalwarts and speakers for the day, for 2 days, and looking forward for good learning, great exchange of ideas. And again, congratulate the department, congratulate the entire faculty of electrical engineering and the BTech division for such wonderful endeavor. Yes, thank you.
Thank you, ma'am, for your warm words and appreciation. Now, different HODs of our other departments, Department of Civil Engineering, Mechanical Engineering, ECE, that is Electronics and Communication Engineering, Computer Science Engineering, they are not with us right now due to maybe classes or they may be associated with some other work. Still, dear greetings are with us. Now we have our Assistant Registrar, who is also the HOD of the Physics Department, Professor Dr. Labakanta Mandal with us. Sir, I request you to please say a few words.
Thank you, Afak. Very good morning and Happy New Year to all of you. Okay, it's a very great pleasure to say something. It's really an opportunity, not only our student, also our departmental colleague, as well as the other interdepartment students also. The topic is very important, and really I am also very much interested in the electric vehicle. Sometimes I have certain interest in this topic also, but due to some other scenario, I could not able to do that work on electric vehicle. Sometimes I have also interest in this topic. It's our great pleasure to welcome the delegates. They are really eminent professor of different institute, and I hope this arrangement for those the students, they will enjoy and learn lot of things. I hope a grand success of this seminar. Thank you. Thank you, everybody.
Thank you, sir, for your warm words and appreciation. TIC of the Department of Mathematics, Professor Subodh Chandra Bhuiya sir, is not with us. So now I request the TIC of Department of Humanities, Mr. Pradeep Kumar Mandal sir, to say a few words. Pradeep sir. Okay, it seems that maybe sir is busy with some work. So I would like to invite the TIC of the Department of Electrical Engineering, Professor Mr. Subhajit Roy, to say a few words.
Thank you, Afak. Good morning to everyone. My group director, sir, all the deans are present here, assistant registrar, sir, and obviously Debashis, sir. Like already, my HOD, sir, has already shared his good wishes from the department point of view to the conveners and organizing team. I also like to share my good wishes to the organizing team that they are really making a good program, and I wish that it's a grand success for the program. And I will obviously be there all the sessions and try to get my knowledge from these dignitaries present. That Debashis sir is really, he has visited a couple of times, and whenever I used to listen his lectures. It's really great for me. So thank you, Afak.
Thank you, sir. I take great pleasure in informing you that besides all the dignitaries on Google Meet, we have over 100 plus students watching us live on YouTube. Now, I would like to introduce the eminent speakers. For today, we have Professor Dr. Debashis Chatterjee, who will be taking on the first session, that is the pre-lunch session, and the post-lunch session will be carried out by Professor Dr. Jitendranath Bera. And for tomorrow, we have Professor Dr. Sovan Dalai for the pre-lunch session and Professor Dr. Debangshu De for the post-lunch session. Without wasting any more time, uh, a virtual felicitation of the distinguished guests with a bouquet and with the lighting of the holy lamp. Let us begin today's session by the introduction of our first speaker, Professor Dr. Debashis Chatterjee, sir. Professor Dr. Debashis Chatterjee received his B degree from Jadavpur University in the year 1990, and then he went on to pursue his MTech degree from IIT Kharagpur, which he completed in the year 1992, and then he received his PhD degree from Jadavpur University, Kolkata, in the year 2005, all in the field of electrical engineering. He is currently a professor with the Department of Electrical Engineering, Jadavpur University. His research interests include electrical machines, variable speed drives, electric vehicles, renewable energy generation, and power quality study. He has published over 65 international journal papers in IEEE, IET, Elsevier, Taylor and Francis, Wiley publications, and over 70 conference papers, of which 68 international IEEE, IET, and 2 national IEI. He has guided 14 awarded PhD thesis with 7 ongoing and 34 ME awarded thesis. He had visited Technical University Brunswick, Germany as research fellow under TechIF program Government of India in the year 2005. Besides his academics, he also possesses industrial experience. He has been the assistant manager lighting electronics design and R&D with Philips India between 1999 to 2002. He was associated with Crompton Cribs, where he was a senior executive industrial automation between 1995 to 1999. And then he was senior executive automation and design for the National Radio and Electronics Company Limited between 1992 to 1995. Now, sir, I would request you to please illuminate us with your enlightening lecture.
Okay, so thank you and good morning to all the respected delegates and the students who are here to interact with this program. Now, again, I am sending a very warm, happy New Year congratulations to all of you also. Although the new year is also within the home, but still we should hope that the situation should improve gradually, and we become we have to lead a normal life in future, in near future rather. Today's lecture actually is the topic. What I have decided is that control of electric drives for the vehicular system, right? And then we will have some basic discussion over vehicular system also, like what are the basic configurations and what are the types of motors, characteristics, and then comes the drive. Okay, so from the basics we will start. And at the same time, you can also interact with me if you feel that this person is still not understandable or something. It's not. I will try to explain in a lucid manner so that it becomes easy for you to understand. And secondly, those who will be finding out their research work in the same field. So I will be giving you some indicative measures that these are the fields where you can start or you can do something, where you can contribute. And I hope a lot of jobs will be coming up in next 10 years for this in this area, because as per the national directives and also international directives, so the vehicles are going to get converted to electric vehicles very soon, and then all the methodologies what they adopt now for normal fuel-based vehicles, so will be changing, and you will get ample opportunities in the industries as well as in the research field also. So with this, I'm starting my lecture. So I'm going. I'm putting up my camera and at the same time going in presentation mode. Okay. So. So it's visible to you.
Yes, sir. Yes, sir.
Yes, sir. Huh?
Yes, it is. It is.
Okay, so this title is actually techniques for vehicular types. The modern train actually. Modern train means modern machines, modern control, all those things. So it is very difficult to cover because it is such a large field, you know. Difficult to cover in 1.5 hour or 2 hour, whatever I can find time. But still, I will give you a introductory things so that you can build up on that, and in future also. We have been doing this research till 10 years, where we got some central government funded research on electric vehicles. Back in 2010, 11. So okay. So now, first of all, the question is why electric vehicles? Because we have been using this normal petrol or diesel vehicles since long back, and we are comfortable with that. So, and now there is a step change is coming, so that we are going to shift our focus from the normal IC engine based vehicles to electric vehicles. Okay, so if you see the major turn around is because that these vehicles they use petroleum as their fuel. Okay, the petroleum has got several limitations, in terms of nature or in terms of its capacities, you can say, in Earth. So actually, you see that petroleum that reserve is also diminishing, first of all, and secondly, usage of this actually emits a lot of polluted gases in the atmosphere. Okay, so now there is a data which is here to give us certain idea regarding how much greenhouse. You know what is greenhouse effect? How much greenhouse gas is emitted by different sort of industries. Now you see that the major part is through energy industries. This is 28%. 28% is energy industries. Okay, and then next comes transportation, which is 23%. But rest of all are in between. Maybe say 11% is not getting the view properly. 11% is manufacturing industries, and 14% is other. What is this one? Households. 14% is households, and then industrial process and all. They are almost lower than what we have for this either transportation or energy industries. Now, energy industries we cannot avoid because we are still using a lot of say conventional energy like thermal power, then nuclear power, etc., which actually is not emissive type, but the thermal power stations, they are emissive type. So therefore we get this 28% emission from this energy industries. But if we somehow can cut short this transportation, it will save the atmosphere to a large extent, because it is almost 23%, 1/4 of the total. Okay, 1/4 of the total. So then came the thought that why not use this electricity as a drive system, right? And those electricity made from not from the normal sources like conventional sources like a normal grid. So it should be generated from you can say green sources like wind, PV, etc. And that will be used to charge the batteries, or in turn some fuel cells. Not fuel cells are not charged, but actually with the help of fuel cells. So that do not require any conventional energy that is being produced, like you say thermal energy, emissive type. So then this became the driving force actually behind the electric vehicles. Now technology is ahead. You see the EV technology trend. Now we are going to the sort of say zero carbon electric vehicles. Zero carbon means actually no emission at all. So batteries will be there, and the batteries will run the electric motors. There is no emissions. Now if you see the this is a target, okay, zero carbon electric vehicles till 2030 or 2005, whatever it is. Each country is taking their own timelines to convert their vehicles. Now, the technologies, as far as the technologies are concerned, EVs are divided into three basic categories. Okay, the first one is battery electric vehicle. Okay, battery electric vehicles. I'm putting my BEV. And second is plug-in electric vehicles, plug-in hybrid vehicles, PHEVs. And the third one is fuel cell electric vehicles, FCEVs. So these are the three major players. Okay, so battery electric vehicles are very much available everywhere. You can see, like say motorbikes, some cars also are coming. But this hybrid electric vehicle are the a future actually. because there we have a backup and show you the different configurations. And then fuel cell electric vehicles, they are for big vehicles, actually, big vehicles and having a larger costly vehicle. General person generally cannot afford this, but actually for large transportation, public transportation system, so this fuel-based electric vehicles are coming up these days. So now coming back to the general configuration. Now, general configuration, I have taken it from some earlier days literature. So this one, so this it indicates gasoline, but actually it is petrol, diesel, whatever it is. So the general version is this, that the gasoline engine or the petrol diesel engine, and there is some transportation system, that is transportation of this generated power to the shaft, drive shaft, and then there are wheels. So this is the configuration. Okay, transmission system, you can write that, power transmission system. Now this is general, but then if you go to BEV, battery electric vehicles, it is actually battery which is acting as a fuel. Earlier we had gasoline engine, gasoline acting as a fuel, but here we have battery as a fuel. And then motor, actually motor generator is written here because simply, so normally when the motors are braked, actually a lot of energy is lost actually in the brakes. The kinetic energy is lost in the brake shoes and all. So there are electric brakings that are being implemented these days. So at that time, these motors act as generators and the energy is fed back to the battery. So the battery get recharged from the extra kinetic energy that the thing is having. So this is another issue. So regenerative braking based electric drive. So this is some way of research and better topologies they are being invented these days. So then the configuration, if you see that battery electric vehicles, so this is the configuration 1. That means this is electric. The EM means electric motors. Okay, the EM is electric, is the battery. So we can have this four-wheelers I am just talking about. So we can have the electric motors coupled to these two wheels, and then another electric motor that will drive this different to the back wheels. Okay, so then this is one you can say category or one combination. Now this power flow are actually both ways. That simply because that what I have said, that they will be working under regenerative braking mode. So therefore, whenever it is under braking condition, so the power can flow from the machine to battery. So the same way for all this. So actually, then this is one configuration. Then the second configuration is we have motors connected to all four wheels, right? System, and this is electric machine. This is another electric machine. These are four. So actually coordination. So earlier you see that battery people need technology long back. Actually, it's not that today only we are able to know with help of very great research. It is not that people used to know long back, even 150, 150 years, 200 years back. But the problem was actually how to implement this was not the technology this was not available with us. This is available. This is possible these days simply because that we have these days a low-cost processor with high computational ability, right, easily available. Now you see the first year or second year students who have been listening to this lecture or who have joined this webinar. So I feel that many of you actually
YouTube. I request you to wait. Sir is with us once again now. There was some connectivity issue.
So is it now audible?
Sir, yes,
Yes,
sir, it's
sir.
audible. Yes, sir,
Okay,
it's
okay.
audible.
Now I am going back to the screen.
Yes,
So
sir.
you just tell me whether it is available to you or
Yes,
not.
sir. So we are there, sir. We are there.
So is it the screen is appearing to you?
Yes, sir. Yes, sir, it's appearing. It is visible. It is visible.
Now
Configuration one.
configuration two you have got.
Yes, sir. On the side, it is shown configuration 1 and 2. Right now, you are discussing about, yes, now it's visible, sir. Configuration 2.
Maybe suddenly it has become slower. So the loading to the net is changing actually.
Yes,
So
sir.
that
It
is why.
happens, sir. It happens. Okay, sir. Please carry on.
Okay, okay. So then we were discussing about the second configuration. See that here we have both all the four wheels. They are coupled with electric motors. Okay. Now the thing I was discussing that whenever you have so many systems, like say 4 electric motors means you have 4 electric drives, right? That are separately being controlled. Or in the other case, configuration 1, you have 3, right? So you that you should have a processor which will be able to coordinate, or the hardware which will be able to coordinate among all the 4 drives, so that there is no mismatch regarding speed, regarding turning, etc. All these things. So I was telling one fact that all these things, this technology, what we are doing now is not very new. So people used to know this even 100 or 150 years back. But the problem was that applicability was not possible, simply because we didn't have the fast processors those days, right? We didn't have the fast semiconductor switches those days. So I was discussing that this has been only possible with the advent of power electronics, modern day power electronics, with say fast and high power handling capability switches like IGBTs, power MOSFETs, etc. And then at the same time, high-end processors with high computational ability and with low cost and better applicability. Applicability means that better, say programming facilities. I was just discussing that these days even first year students, they can program a Raspberry Pi, okay, and it is very easily available, and it has got good ability, right? So then the techniques, the drone techniques, the techniques of this robotics and all, they are actually made very cheaply available to all. So this is simply because that the semiconductor technology has drastically improved. Its cost has reduced, everything. So those things are required these days. Knowledge on those hardware developmental abilities. So the other configuration is actually we have 2 differentials with 2 electric machines, okay, and a central battery. So many things will be there. So these are the outer configurations, okay. So these are the 3 configurations for battery electric vehicles. Now when you were talking about 4-wheelers, okay. Now second one among the electric vehicles is hybrid electric vehicles or plug-in hybrid electric vehicles, PHEV. Now here, as the term is hybrid, so you will get both the normal electric motors and generators along with its drive. Now you see the configuration. Here we have a common control system, and then we have a gasoline engine and a motor generator. It can be coupled to the same shaft, right? This is electric motor, right? And this is gasoline engine. Now there is a transmission system and the wheels, right? Now here the thing is that idea is that whenever a high torque is required or some abnormalities have come or the electric machines have failed, so this gasoline engine can drive it. On the other hand, whenever a normal running situation, so we can use this battery and we can have this engine to run for some time, and a generator can be coupled to it so that the generator generates electricity and the battery gets charged. So this is having a most versatile, you can say, configuration in order to have a high reliability with a little bit of, or rather we can say, extra cost, because whenever you are adding up systems for backup, naturally you need additional systems and additional cost, additional space. So for small electric cars and all, this will not be available. So you require a larger car and all those things. So now this is the technology. Now you see here also there are configurations, like the first configuration I'm telling. Hello.
Sorry for the interruption, sir. The presentation has stopped, sir.
Again.
Yes, sir.
Which page?
Sir,
Hybrid electric vehicle, sir. Hybrid electric vehicle configuration. That slide. I mean, screen sharing presentation has stopped. The slide. You can find on the right hand bottom, present now. There is an option in the Google Meet icon.
Right.
So from there,
Why
you can
it is
present the
happening? Okay. Thank you for indication, because see, whenever this kind of thing happens, so please tell me, because
sir, we will, sir, definitely. Yes, sir, it's visible now. Sir, it is visible.
Visible now, huh?
Yes, sir, it's
So
visible.
Second, configuration 1 visible.
Yes, sir, it's visible, sir.
Okay, all right. So now in this case of hybrid, we have both the IC engine as well as electric engine. Now, if you see, there are different configurations that are possible or available, you can say, these days with different company motors, company cars, you can see. This is a fuel for IC engine, okay, fuel injection. Then the IC engine is coupled with generator. So that's what I was telling, that this earlier slide. So this gasoline engine and this motor engine, I just said, they're coupled in the same shaft. And they're coupled. And then we have a battery. We have a battery here, which actually supplies, which supplies the okay. Where it is? Yeah. Battery, which supplies the three-phase inverter rectifier and for the electric motor and for the transmission system. So now the IC engine actually can directly drive, or it can give power in terms of generating some electricity, and then gives to this battery as a charging through this control and rectifier. So this one configuration where we have both IC engine and this electric motor, IC engine electric motor, and they can be coupled together, right? Now the second configuration is this one. So they are actually, IC engine is directly coupled once, or you have a electric motor that is also directly coupled. Okay. Now the battery, that can be, I mean, this inverter is a bidirectional inverter. It can actually charge the battery as well as discharge through the motor. Now, charging the battery, there are several ways, like the motor can regenerate and get, and also the IC engine can have a generator and that can the battery. So that everything is not mentioned here, but it's a symbolic view. So we can have this configuration where we have in the back wheels, we have this differential, and then that is coupled to the electric motor as well as the IC engine. This is second configuration. Now the third configuration is this one. Now where we have the electric motor and coupling, but this IC engine, generator, and battery, I think repeated or what? No. So this generator, this gives power to this rectifier sometimes, or sometimes battery gives power when additional force is required. So actually, when the battery becomes insufficient, so this generator power also will help to pump in additional energy to the motor, so that some high acceleration, or when it climbs up in a slope, all these things. So these are the three basic configurations that are available for electric vehicles. And for fuel cell, I have not shown anything, simply because it is an emerging technology. So instead of all these things, you can have a fuel cell. So that gives actually a DC supply to the inverter. So rest things will almost common. The technological issues are a little bit different regarding fuel cell. So, I mean, I have not covered here simply to limit the time. Okay. So, best is that first study the battery electric vehicles as well as the hybrid electric vehicles. Now, a comparison, I don't go for this type of comparison. I will go for a graph, a plot actually. If you see the requirement comparison, you see from 2011 to 2020, although it is saying estimated, data was on 2017. So that is why it showed estimated. Now, if you see the demand, worldwide demand, the global demand for PHEV, BEV, and FCV. So FCV is very small these days because I have said it is a very costly affair and the technology is not yet very much, you can say, frozen as such, right? So for few of the drives only, you will find that FCV fuel cell based system is there for large motors, large transportation systems, and it has got very high cost. So therefore, you see the segment is almost negligible compared to IPH or BEV. So BEVs are maximum simply because they are having the lowest cost and the size is minimum. It starts from scooters to your say small rickshaws even, and then it goes to a four-wheeler, small four-wheelers. So then, if you see that the research area, they are although confined in all the three, but this BEV and HEV, PHEV, they are having more share. Okay, so then this is the demand, you can say global demand. Then the historical development, I have already told you that how it has come, 1769 and all. Then people had the idea from this first, then here at 1893, from 1900 and all. There we have EV, say 100 years back. I was telling that people knew this from long back, but actually the technology to implement, having the fast-acting processors, having fast-acting switches, they are not available. They are made available from the year say 2000 onward. From 2010 and all, it has become very easy to procure. If you remember those who have been working in this area, not electric field directly, not electric vehicle directly, any power electronic areas, so you will find that the processors in 2000, early 2000, 2001, 1999, like that, end of 90s, had very costly processors of say Texas Instruments, having a limited computational ability. But nowadays we have very high computational ability processor at lower cost. So power electronics, it is the power electronics advancement that is made possible. So, now to skip simply because they are already, I have told you, electronics and all. Now go for the motor characteristics. Means what kind of motor we will be using for this kind of drive system. Now you have seen the configuration, you have seen the idea, why we go for the electric vehicles, and then the motors, type of motors that are used. So usually we used to have soft motors with soft characteristics, right? What is soft characteristics? Which is series characteristics. Now you remember the speed characteristics for DC motor. Now the soft characteristics and the another characteristic, hard or stiff characteristics also. So these two, out of these two, actually, the soft characteristics is only applicable for this motor drives for traction purposes. Simply because, so one reason is that you all know that we have say very large torque at low speed. When the speed is low, we have torque. So at the time of starting, it is starting with inertia, with full inertia. That means with load. So we require very high torque. So that is a well-known feature. But the major feature of soft characteristics is that you see that supposing you have a speed change, right? Now, why speed change is required? Now you see that the tires. If you see the tires, so there the air in the tires that change sometimes. Right from the time you fill in with air and then it runs for 2-3 days. So then slightly you have a shift in diameter, right? You have a shift in diameter, right? So now when you run it, you look for actually linear velocity. Say it is 100 miles per hour, it is 40 kilometer per hour, like that. So now in order to have that with a lower diameter of tire, if you want to maintain the same speed as the slightly higher diameter, so what is going to happen? Your omega r is your linear velocity. So when r is reducing, so omega you are changing, right? Now if you change omega slightly, here your torque does not change much. You see the characteristics. You shift omega by a small amount, right? Shift the speed by a small amount, but torque doesn't change much. But you look at the shunt characteristics or steep characteristics. Now, sorry, if you have a small change in speed, you have a large variation of torque, right? So that makes this actually simply unapplicable to so you require large armature current, right? You require very large armature current or large current to be injected in the machine. So then you don't require that. Small change in speed you require. So most suitable characteristics for driving the electric vehicles or the vehicular motors, you can say. We have different motors that are being used these days. So we have DC series motor, as I have said, shunt motor is ruled out, and a brushless DC motor. Of course, we can shift the characteristics to such characteristics. So they have power electronic converters. Now then, permanent magnet synchronous motors. So they are also a major player these days. Then three-phase AC induction motors, right? And then switched reluctance motors. So these are the motors. They are actually being used these days for vehicular drives. One is DC series motor that was used from earlier, very earlier. Now we have a brushless DC motor, magnet PMSM, permanent magnet synchronous motor, three-phase AC induction motor, or switch motor. So out of which, as you see, DC series was the mother of this, but still we are actually abolishing this simply because. So the advantages you just see here, we have a high starting torque capability. That is, it's the most widely used motor for traction applications since in early 900s, right? Now the advantage of this motor are easy speed control, and it can withstand sudden increase in load. So all these things are there. Actually, any DC motor is having the weak elements, two weak elements, that is brass and the commutators. Now the brass is a very soft and actually with usage, so it gets worn out. So therefore we have to regularly maintain and then change the brushes and all. And if you do not do that, there will be unnecessary sparking and you can say chances of say even fire. And at the same time, the car cannot be driven in different atmospheres, like where we have high humidity level and all that. This can short circuit the computers. So all these things are limiting the usage of the motors. Okay, so therefore DC series motors, although it is the best machine to run, because actually it has got inherent that soft characteristics, as well as it is having a very high capability, and the torque dynamics is very good. So it is getting abolished due to those reasons. So then came the next category, which is actually the brushless DC motors. Now instead of the DC motors, but actually with we instead of a electromagnet, we have a permanent magnet that is rotor, located in the rotor. So it's called brushless because it does not have the commutator and brass arrangement, but its equivalent can be achieved with, like a DC motor. Okay, so the commutator it is having actually electric commutation. So the commutation is done electronically with the help of say inverters. We'll show one thing, the thing which we have done here. So for this brushless DC motor. So because of this ratio, brushless DC motors have got high torque to weight ratio. That means that volume of the motor can get reduced compared to the brushed DC also. Okay, and the efficiency as a whole is very high here because in the rotor we have permanent magnets and there is no current flowing through this required for the rotor. So therefore, one term which is rotor coupler that automatically vanishes. So these motors have got inherent high efficiency as well as very high torque to weight ratio. And then the commutation is electronically done. So there is no question of any sparking, etc. So all these things actually made BLDC motor to be one of the best choices for a small scale EV system, electric vehicle, BEV actually, small scale BEVs. Now, I'll show you some types of this BLDC motors that are available these days. So, in this, the motor is present, the first one is runner type, outrunner. Outrunner means actually the rotor of the motor is outside the stator, and the stator is inside. So, stator can be fixed and the rotor is in the outside, just like your any ceiling fan or any fan you see. What is happening? That the inner part is your stator and outer part is your rotor, isn't it? So similarly here, so we have a rotor which is outside, and this is also called as hub motors because the wheel is directly connected to the exterior rotor. Now I'll show you on photograph. It does not require external gear also. Now you see in bikes, electric bikes, so you find this type of type BLDC motor, okay, where the rotor is outside and we have no gear system is there, directly driven, okay. So this motor takes overall vehicle less bulky and not require any gear system, so that is the major advantage, and it eliminates the space required for mounting the motor. So extra motor mounting area is not there, so wheel becomes okay. So wheel is rotating. So we have a central stator inside the core, and then the outside is rotating. So we don't require any extra coupling. I have said. So then this is the outer cross-sectional view of the machine. So inside we have actually stator and winding. See here, I'll show you with the are you? So inside part you see is shown in black. Okay. Here, inside part you see that is shown in black. Okay, so this is the stator, and inside the slots there will be winding. These are the slots. Okay, now red, blue, and these are your motors. Sorry, permanent magnets. Okay, and outer part is the rotor body. Okay, so we have this outer portion running and inner portion as stationary, which is the middle of the wheels, and the windings will be there inside. So now this is the type. Picture of the hub motor. So outside there are tires, and inside you have the rotors, and you have a stator in the core like this. And then the stator is being supplied to the drive system. These are the electric wires that are going into the stators. Okay, and it will have some sensors, hall sensors, etc. So this is the picture of the hub motor. Okay. Hub motor is in the category of outrunner type BLDC motor. So now in runner type, the second category, okay, in runner type BLDC motor. So in this type, the rotor is present inside and the stator is outside. Hello, am I audible?
Yes, sir. Yes, sir. You're audible, sir.
And this,
Yes, sir. You're
acha,
audible.
screen is also visible, no?
Yes, sir. It's visible.
Okay, okay. Actually, another sound came, so I thought some disconnection has appeared.
No, sir.
So,
You are audible, sir, and visible also the screen.
all right, all right. So this is inner type BLDC motor. So in this type, rotor of the motor is inside and the stator is outside, like conventional motors. The motor require external transmission system. Like say here, you require external transmission system, belt or chain, whatever it is. And as you need transmission system, so it becomes bulkier. Okay. So actually, you require additional space for motor mounting, and the transmission systems will be there. And here, actually, three-wheeler manufacturers, actually auto, they are using this because this require a little bit larger power because the chain drives and all motors having a larger power. So, and low and medium performance scooters are also there, but normally they are used as hub motors, the scooters. Okay, and these are widely preferred motor for electric vehicle application. Now, overloading, reducing its life permanence, that is a different issue. There is a disadvantage of BLDC motors because after repeated usage, it can demagnetize the magnet, so the performance deteriorates. And to produce same torque, you require more armature current. Now, if you require more armature current, naturally the stator gets overloaded and the chances of failure comes. So after 10 years or 15 years of drive, continuous drive, you don't find these systems are actually working. So you require regular maintenance or change of permanent magnets, etc., etc. So now show you that picture for the surface mounted BLDC machine inner rotor type. So here this one. So this is outside. We have a stator. Now slots are there. So the windings will be there in the slots as the arrow shows, and these are the rotor outside. These are the rotor outside permanent magnets. So north, south, south. That is why the change of color is there. So this is inner rotor type, and this is surface mounted. That means that rotor on the rotor surface we have the permanent magnets mounted. Now this is the motor, in-runner type motor. I mean, we have windings that are here. Winding connections that are here, terminals. So now this is a picture from a standard 48 to 96 volt 10 kilowatt motor, and this is the power transmission system. You see, this is the wheel, and we have a drive like this or some grouped belt like this, and this is the motor. So motor transfers here, gear arrangement, and then this transfer to the main shaft. This is the transmission system is there. So it requires larger space. And that is why normal you won't find this. I mean, some high-rated, high-speed two-wheeler machines you will get, and then otherwise it's mainly in three-wheeler drive systems, electric autos and all. Okay, so this, and then this is interior permanent magnet inner rotor machine, inner rotor interior permanent magnet machine. So we have rotor structure is given. This is a shaft, and the permanent magnets are embedded inside rotor. Okay, so then the third category is actually this inner rotor type in interior permanent magnet IPM. We say these IPM machines are you can say compared to the surface mounted techniques because their maintenance is easier, magnet replacement or something. They're easier, so are more widely used compared to the interior permanent magnet. So I am not going in detail for this one. We have a third category, that is permanent magnet synchronous motor system. Permanent magnet synchronous motor, PMSM. Now these motors are similar to BLD motors, right? You know, synchronous machine rotor has got the permanent magnets instead of electromagnets. For synchronous machine PMSM, rotor has got permanent. So therefore in the BLDC machine also you have seen, which is inner rotor type, the rotors are having permanent magnet, either surface mounted or IPM machines. interior permanent magnet machines. So here also it is similar, but the stator winding is such that we do not have a trapezoidal back EMF here. We have a sinusoidal back EMF for PMSM. For for BLDC machine, we have a back EMF waveform which is trapezoidal in nature. So we will show you later on what is a trapezoidal back EMF and what is a so you will find it sinusoidal. If you see BLDC machine, you sense EMF, the winding is made in such a way that you have got a trapezoidal shape of the EMF waveform. Okay, EMF waveform. This has got several advantages, disadvantages, etc. But that all things cannot be discussed. But just to remember, the BLDC have got trapezoidal back EMF, BEMF, and then the synchronous machines. PMSM has got sinusoidal back EMF. And then these machines have got higher power ratings. Now, out of the three machines we have discussed, like say BLDC machine, then brass DC, then this PMSM. So PMSM is highest among the three. So it's the best choice for high performance applications like cars and buses. The rating is enably high. We can build this machine at a higher rating, and then it is having almost a higher cost, much higher cost compared to your this BLDC machine. So instead of higher cost, this is proving to be, I mean, a very good choice for building up electric vehicles for say large drives like cars and large of the buses, etc. And it is providing a challenge to the parallel. It is running parallel, you can say. It is providing a good challenge for the induction motors. Magnet. So simply there is no you can say current in the rotor. So there these machines will have got better efficiency. But the problem is that while speed controlling, when you need to control the flux, so if you want to go to a higher speed, right? So you require a field weakening zone. Okay, so field weakening zone, where we have, of course, nowadays good technologies available. So with the power which is actually given, or the flux which is set up by the stator has to act in opposition with the flux. So therefore field weakening is a little bit difficult here, but with the advent of new technology and new processors available, so it is not a problem. So it is getting more and more popularity these days, this permanent magnet synchronous motor compared to induction motors. Although induction, one way it is the best, it is the most rugged machines and having the lowest cost. So these two are the deciding factors. So where to use when. Now PMSM is costlier than BLDC motors. That is okay, true, as I have said. And mostly automotive manufacturers are using PMSM motors for their hybrid and electric vehicles. That's what I'm telling. So example, this Toyota, Chevrolet, and all these machines, Nissan, and they are using this PMSM as their main for propulsion. So then this is the inside view. So some view I have got from other sources. And then come the fourth one. This is three-phase AC induction motors, right? Three-phase AC induction motors. Now you see, induction motors are nothing new to you, so I don't discuss much like that. So its main advantage, I've already told, that it is the most rugged machine when you go for the squirrel cage type of machine, as well as the lowest machine among all the categories of electric machines that are used for electric vehicles. Now, from a particular rating, of course. So you don't get an induction machines of 200 watt and you find the compare cost with BLDC machines, because nowadays permanent magnets are available very okay. So therefore, for very low categories, BLDC machines are the major player. But you go to a category above 5 kilowatt, 10 kilowatt, like that, 6 kilowatt, 10 kilowatt. So this is the induction machine. Okay. Now we have got various control techniques available for induction machines like FOC, V/F, etc. Even DTC, direct torque control, are there. So I have forgotten here DTC. is another technique that is used nowadays. Although DTC has got inherent problem at the low speed, having some oscillations. So anyway, so these are the maximum torque is made available at starting, which is suitable for traction application. You can have different rotor structures like a deep bar rotor, or you can say double cage winding, which gives you a larger starting torque. And induction motors also can be designed up to an efficiency of 92 to 95%. Now, one thing I am telling you that as I have said, that the synchronous machines, permanent magnet synchronous machines, are having the better efficiency compared to induction machines. But if you consider the drive plus machine machine efficiency, because it is the battery which is supplying to battery, the total efficiency is the most important thing. It is not the machine efficiency. It will have the converter efficiency also to be taken into account. So there, if you multiply eta 1 to 2, where eta 1 is the converter efficiency, eta 2 is the motor efficiency. So you get actually these two machines are almost comparable, right? So the converter efficiencies are slightly higher for induction motor drives compared to slightly lower at PMM drives, because of several reasons, as I have said, that field weakening and all this requires additional hardwares and additional say switchings and all. So this increases the cost sometimes. So therefore, actually, you see that the overall efficiency seen from the battery end is almost same for with these two machines, and then it becomes the manufacturer's choice to choose anything between these two, right? So these are the standards. I don't waste time here. Now, adjustment of B induction motor is easy. B means flux density. Okay, that's telling that adjustment of flux density. That means when you go for field weakening zone, so actually induction motor control is very easy compared to the synchronous machine PMSM control. So then this becomes this advantage gets squared up when you consider the converters. So therefore, it becomes a manufacturer's choice. This is the torque speed characteristics. So you see that the modified torque speed, so high torque can be possible. So like this can be possible even during starting. So there are this time here. So now you see I have mentioned few companies like Tata Motors are using induction motors. So TVS trying to use induction motors. So the research input what I get from my students or from the companies working in the EV electric vehicular region. So this the information this three-phase induction motor as propulsion. So induction motors are the preferred choice for performance-oriented electric vehicles due to its cheap cost. That's what I am selling rugged. And Indian Railways has started replacing DC motors with AC induction motors. So this is also another major consumer for very large motors of the order of several hundreds of kilowatts, 500 kilowatts or like that. I don't know for the comparison. The peak one is switched reluctance motor. Switched reluctance motors. Now switched motor, it falls under the special machine category of your syllabus. Having some saliency, right? And there is no winding in the rotor. So inherently, any magnet or any so as a part of the manufacturing point of view, from manufacturing point of view, you can say that this machine has to be the cheapest one, because the rotor you only require a machining part in the rotor. Okay, but the stator is having windings. And therefore these motors are one of the cheapest motors, and at the same time control of these motors are also not that much problematic, and inherent efficiency is high, as because here also you find the rotor does not carry current. Only during transient condition there could be some eddy currents that are induced in the rotor, some eddy losses or losses that can happen. But otherwise, this machine is very good and it's very rugged. It's very rugged. Simply simple in construction and robust. Okay. So therefore, these machines are slowly gaining its importance in the field of electric vehicular drive systems. Now, SRM offers high power density. It is having high power density, which are actually required characteristics of electric vehicles. Okay, robustness, high-speed application is easily high acceleration, low inertia, and rotor less with high acceleration. Okay, so then all these things are making it advantageous. But only thing is that its drive system has to be a little bit complex. The only thing, and the biggest drawback: complexity in control entries in the switching circuit. Drive system is a little bit complex. So therefore, this requires some space, some additional devices. Now that the failure comes mostly from the electronic circuits, expected to come, you can say, because that can fail instantly. Okay, a mechanical system is very difficult to fail until you design very wrongly. Electrical system is somewhat lesser because normally electrical system failure is due to heat only. So heat actually requires a few hours, maybe 1 hour, 2 hour time before that you can get the indication. But the electronic system, it can fail instantly. Whenever you supply some instant high currents, it will fail, right? So therefore, electronic systems are the most weakest part. Now, in terms of reliability point, when you consider the overall drive system, SRM a little bit behind. SRM falls a little bit behind. So therefore, SRM is although into picture, but all these things are to be solved before it gets introduced in a rigorous way, or in a more in a larger extent, you can say. So once SRM enters the market, it can replace PMSM and induction motors in future. This is actually future technology. So you can have some of your research in the field of this, any of these three, and where PMSM gives you the best opportunity, because if you do some minimum incremental work on this field, so your literature can get published also, right? So the emerging areas of research field. Right? Then pictorial view of SRM. These are the stator windings, as I have said, and the rotor is simply machined rotor. So this is like nothing is there. So then this is the view, stator and the rotor, stator windings, and this is the rotor teeth and all. Now, actually, I have discussed the different motors, right? Different motors, and earlier their configurations and all. Now, just few things I'll be telling you that how to select, means which one to select. The thumb rule that is being followed by industries these days. Now, to select the appropriate electric vehicle, the first requirement is operating conditions and the cost. Operating conditions means whether you require a high-speed drive or you require a high-torque drive, or actually what is a type actually. Whether it is a very large drive, means bus or scooter or three-wheeler, and then the cost actually means overall cost, whether it will matter much or not. Because when you go for four-wheeler, you see it is the cost will be a second choice, simply because the reliability becomes more important, right? Because once the car gets say you can say not under running condition while a person is on the way, so it is very difficult for him to take this car to a station, or he has to inform somebody he will come from the manufacturing end, and then he will rectify the problem and then he will start. But for small drives like cycles, like say even scooters, people can themselves go and then go to the repairing shop and then do it. So then reliability becomes choice more and more better important choice for you can say larger and larger rated drive. This go-kart vehicle, two-wheeler applications which requires less performance, mostly less than 3 kilowatt, at a low cost, it is good to use BLDC hub motors, right? It is thumb rule. But when you go for 3-wheelers and 2-wheelers, the next page I am showing, it is also good to choose BLDC motors with or without an external gear system, 3-wheelers or 2-wheelers. Now for high power cars and trucks, the ideal motors would be PMSM or induction motors. So their cost is the second choice, but you require to drive it, you require to have more reliability, you require to have high torque, high starting torque. So all these things. So then this becomes the price. Now again, slowly I will enter in the drive technology. Drive technology means what are the configurations, and some converter techniques I will discuss before ending this session. So block diagram for electric vehicle powertrain. So now if you look here, so we have shown these are the 4 wheels, right? These are the 4 wheels, and this is the differential and then transmission system, and this is the electric motor here. So now the motor gets power, variable frequency power or whatever it is, from a 3-phase inverter, right? From a 3-phase inverter, right? 3-phase inverter gets power from a DC bus, right? From a DC bus. Now this DC bus is usually at high voltage. Now where the DC bus is powered, now you have a DC-DC converter, DC-DC converter that is actually here, which is charging a supercapacitor, charging or discharging. And now these DC converter, there is another DC-DC converter which is coupled to the bus. Actually, all these are bidirectional converters. You know, sometimes this converter can supply energy, and sometimes it can take energy to charge this supercapacitor. Now this converter is also bidirectional, so it can supply energy to the bus. It can take energy to charge the batteries. Okay. Now the battery is getting powered from this charger. Okay, from the charger. So the charger is getting connected to the grid. So this is the major structure. Now another DC-DC converter. This is LV-DC-DC, right? These are high voltage. High voltage means not very high voltage. It used to be according to the motor rating, right? So if you have a 12-volt battery, so you would have a DC boost converter to drive it to, say, if you motor of 48 volt, or it depends on the motor rating. So you have to lift it up to 48 volt. So now actually there are other systems in the motor, like the lighting systems, the horns, the speedometers, etc. They do not require voltage, high voltage 48 volts. So another DC converter to convert this into a usable voltage for those additional devices, low voltage. So that is a 12 volt, 6 volt, like that. So this is the basic architecture for the, okay. Now again, I am showing it in a block fashion. This is the electric motor generator, traction drive. So it is coming. So the battery can be different. So I have no time to discuss about the types of batteries. This is also another important issue these days. Electric vehicle is a very large area, So I saw batteries and the charging techniques and its discharging techniques and all these things. Those E2V and V2E. I think the Indian speakers who will be covering the grid portion, they will be. Then we have this one, DC-DC converter, and then this is 12 volt rail, and this converter is for high voltage. This battery, and the battery is providing power to the inverter, and all these things. And then this is the infrastructure for charging. Now this is to DC with power factor controller, right? Now this and battery monitoring and management is also another area. So it should indicate the state of charge, what is the voltage, what is the life remaining. That will be helping. But assessment of life or condition monitoring of the batteries also is becoming another topic these days. So this is the basic architecture. Now we go classification of different converters. So you all know DC-DC, buck, boost, etc., Z source, etc. But the types of converters we use for the traction system, we will go straight away to that. Already 40 around. So another 20 minutes I'll be ending, because from 1:30 I have another program lecture actually for my students. So then DC as I said, that this converter, so this converter, or in this figure this converter, DC converter. Normally it gets lower voltage depending on configuration like this. So it gets it's a lower voltage from the system. Right? Now this has to boost up. This has to boost up the voltage to get a DC bus. DC bus of rated voltage. If you design the motor at such a low volt rating, the current rating will be so high because you have to supply certain amount of power, say 1 kilowatt, 5 kilowatt, 10 kilowatt. The current rating will be so high that the motor becomes bulky and all. It is difficult to make the winding possible. And actually, what happens, that voltage level is raised to have a appreciable lower current, flowing through the machine. Now a higher voltage. So the general boost converter, earlier we used to use that, how a boost works. Okay, so this we have a smoothing capacitor and all. This is a general boost converter for the first choice. Now a moderate output voltage gain can be obtained here. Here the voltage gain is usually less than 400%. That means 4 times. So if you get a voltage of 12 volt battery, so it can have a 48 volt output at the most. Okay, and the output is better to have 3 to 3.5 on the for the. I am not going into that. And the efficiency is also moderate here, only 83 to 85% at full load, because efficiency becomes lower at lower load. If you remember your things, because the switching losses and all, they remain, they do not change much. Okay, so therefore efficiency gets lowered. So always efficiency near full load is designed. So the output voltage of single polarity is possible, but the advantage is that the cost is lower. Okay, so single polarity, what I am saying, that it can supply only this positive and this negative. It cannot make reverse. So we don't require also these days. So the cost is lower. So then these are the drawbacks. Drawbacks means advantages means this is not an advantage. Efficiency and all this can be the features. Now drawbacks are actually high voltage gain is not suitable, greater than 400%. So sometimes I'm saying you that for up to the motor ratings up to say 48 volt is okay, allowable. Now if you go up to a rating of say 5 kilowatt, 10 kilowatt or so, say 48 volt motor will be having a very large current rating, and therefore the overall machine weight and cost and all will differ. Okay, so therefore you require a higher voltage for that, maybe 100 volt, 100 like that. So therefore this higher voltage gain is not possible. It's not suitable or possible for this. Now parallel arrangement of power switching is required for high power. So those things are there, but actually these are disadvantages. Extra stages are required for short circuit protection. So there is no short circuit protection. So then this converter was the first choice. Okay, but several disadvantages. The second thing came after that: interleaved boost. Interleaved DC converter. Now interleaving means actually we have similar boost type of converters. They are actually fed like this. This is one leg.